today, what we hope to share with you is how do we go about finding a great job? And as mentioned, I think the key message that we want to say is that you shouldn't wait until you have graduated from university to think about this question, but you should actually be starting to think about it today. And so the fact that you guys are joining us for this talk, I think that you have already taken the first step, to start thinking about this. So that's great. So let me just quickly run through a few slides that I prepared for this talk over here. And so the first thing I think you kind of want to ask, and if you haven't asked that question, I think it's going to be a valid question. Why do you want to listen to what I have to say? Why is it that I'm going to have anything valuable on top of what you have already heard or what you find online over there? So my first job over here is to convince you that I'm going to have some valuable advice to you. And so how am I going to do that is I'm just going to show it by numbers. We are engineers by training, right? So I'm going to show you some data over here. So this is actually the employment statistics that MOE compiles every year. So this was from 2019 over here. And so if I just pull out the NUS and NTU because the other universities are relatively small. So basically I just pull out the NUS, NTU numbers. And if you were to look at the numbers over here, uh, the 75th percentile for the full-time employment rate was actually 93.1% over there. And the 75th percentile for the mean salary, it's 4,095. And this is a pretty high salary compared to what I got when I was graduating. So, but that seems to be the market rate out there these days. And if you look at it, there are actually only 8 degrees in NUS and NTU that exceed both of these criteria. And so these are the 8 ones over here. Okay, and so the rest of them, they could have high salary, but their employment rate may not be that high. Or they could have high employment rates, but the mean salary may not be that high over there. And what I want to highlight to you over here is that our department, Industrial Systems Engineering and Management, is actually one of them over here. And in fact, our employment rate is actually 96.5%, which is significantly higher than the 75th percentile. If you look at the mean salary as well, we are 4,451, which is also significantly higher than the 75th percentile over there. In fact, if you look at this pack over here, this 8 that exceeds on both of these criteria, we are actually doing pretty good over there. Okay, and so what I want to share with you, I hope this is enough to convince you that perhaps this person who is talking to you right now has some valuable advice in terms of how do you go about to be able to secure good employment. Okay, the other point I want to highlight over here, which later I'll explain why it's important, is that our graduates not only are getting good employments, they are actually being employed across a wide range of industries. And so we have our graduates going into business and finance. That was pretty popular with some of our graduates. We see them increasingly going into digital technology as well. I think this is a very hot area these days. Government and service industry. So we see quite some of our graduates going into the government agencies or going into the service industries, for example, hospitals, hospitality, and so on. We have quite a few students who are in manufacturing as well. And finally, supply chain logistics. That is another area that hires a lot of our graduates over there. So these are basically just some of the job titles of our graduates who are working in these different industries. So I'm just going to, due to time, I probably don't want to take too long. So I'm going to quickly just run through my slides over here. Later on, I will give you a link to our department's website, and all this information is going to be there as well. And at the same time, I think we have recorded this. So if necessary, you guys can approach Sarah to find out more information. Okay, and so with that, just a quick summary. If you look at our graduates, they are highly paid, and then they are resilient, and that they are able to find employment in an industry of their own interest. So through my first chart, I've shown you that they are actually they are able to seek out the best paying jobs over there. But not only that, the second point that I highlighted, that our graduates are actually finding employment across a wide range of industries. That is important because there are going to be industry-specific shocks that could happen. So one example is this COVID-19 situation, which has hit our hospitality industry particularly hard. So if you have a versatile set of skill sets, that can be transferred across different industries, then that is going to make you more resilient. But I think the third point, which I think doesn't receive enough attention, which personally I think it's important, is that if you are versatile, then you can choose which industry that you want to go into. I think very often we don't hear this, but my advice to you is that at the end of the day, you want to find a career that you are interested in, because you're only able to dedicate yourself to your work only if you are going to be interested in the particular line of work. If every day going to work becomes a chore, then it becomes very hard for you to perform well in that particular line of work. Okay, and so I think that's where versatility is important, not only to protect against unforeseen situations, but also for your own individual well-being and actually for your own career prospects as well. You are only able to perform the best in an area that you actually like. Okay, and so with that, I hope I've convinced you that the employers out there are actually very interested in our graduates. And so which brings us to our topic for today. How do you go about making yourself appealing to your potential employers over there? And so that's the question that we want to talk about. Why do employers out there actually hire our graduates? And so I'm going to highlight two things over here. Firstly, our graduates have useful skills. I'll say that our graduates have useful skills. And the second thing which I want to dwell on more is that they actually demonstrate the value that they can bring to the organization. Okay, so first, let's talk a bit about useful skills. So our graduates are versatile. So they have a set of analytical, computing, and system skills that can be applied across multiple industries. Okay, so that's why they can find employment across different sectors. And they are objective problem solvers. So when we tackle a problem, we don't just go by intuition, or very often if you go into a business meeting, it's very often the person who bangs the table the loudest that actually gets his or her way, or the decision is made based on whoever speaks the loudest. But a company that runs like that is not going to perform well. A company needs to actually have a very systematic way to analyze the different solutions, to look at what is going to be the best resolution towards an issue, towards a problem over there. And so that's what we train our undergraduates as well. And lastly, when you deal with real world problems, you're going to realize that it's going to be complicated. It's not going to be a well-defined homework problem that you do. Okay, so there are many things that you need to deal with. There are many uncertainties that you need to address, and there are many factors that can potentially affect the outcome over there. So these are the things that our graduates are able to address over there. Okay, so as mentioned, I don't want to talk too much about this. So very quickly, let me just talk about two skills in particular. One is the ability to perform optimization. So for example, when we look at the manufacturing industry, right, what happens over here is that one production line is very often used to produce multiple products. So one production line can produce product A, product B, product C, product D, and so on. But the problem over here is at any point in time, we can only do one. So I have to produce product A, and then once I'm done, I will switch over to produce product B. But there's going to be switch over time. There's a lot of manpower, there's a lot of resources required to recalibrate my production line over there. And so what happens is ideally, I hope to minimize this number of switchover. But unfortunately, there's a limit to what I can do because I have my delivery deadlines, right? So by this time, I need to have this amount of product A. By that time, I need to have this amount of product B and so on. And so this essentially is an optimization problem. How do I come up with the schedule such that I'm able to minimize the number of switchover that I need to do in order to maximize my output, but at the same time, such that I'm still able to meet all these delivery deadlines that I need to do. So that's an optimization problem, and that's one skill that we teach our students. And you realize that optimization occurs everywhere. If you go into the logistic industry, the problem then becomes, I have 1,000 delivery points I need to make. But what is going to be the most efficient way that I can actually minimize the number of trucks required? So a foolish way of doing it is to assign one driver to make one delivery to the east, and then one delivery to the west, and then one to the north. A more efficient way is to kind of cluster them over there. Okay, so that in itself is another optimization problem. If you look at business and finance, how they allocate their capital to make investments while keeping their risk manageable, that in itself is another optimization problem. The other skill that is very useful that our graduates have is the ability to perform simulations over there. So what you see on the left over here, this is essentially just a simulation of a warehouse. And so once we have a simulation over here, we can test different types of solutions. And then from there, look at what is going to be the best decision over there. I'll go forward and then later on, I'll come back to this with a more concrete example. Okay, and so now I finally reached the point that I wanted to talk a bit more about, which is demonstrating your value, which if anything else, I hope that this is one thing you will take away from this talk today. You cannot assume that your potential employer is going to know how you can bring value to their organization. The duty is on you as an interviewee to demonstrate to your interviewer that you are able to bring value to the organization. And so how we do that is that for our students, all our students have to take this systems design project, which is essentially a project that is done across 2 semesters, which means 1 academic year. And so for this project, what we do is that we get our students to be assigned to a company to solve a significant real world problem. So it's not a small problem. So that's why it's across 1 academic year. So they want to tackle a real significant problem over there. And we do hear of our students actually getting job offers at the end of their projects. So if you do well in this project, then the company straight away can see the value that you can bring to them, right? So there's no need for them to interview anyone else already. So what I want to do is just quickly share with you 2 of these projects that I have supervised previously. So the first one over here, it's done with Infineon. So if you're not familiar with Infineon, Infineon is a semiconductor manufacturer in Singapore. So when Infineon approached us, they were asking us to look at their factory floor and ask us to help improve their efficiency, to improve their throughput over there. So these are the students that were assigned to this project. And so basically they just began by just going down, talking to people. So they perform their analysis. You go down to the ground, you talk to the different people, you talk to the managers, you find out where the potential problems are. And once they kind of figure out where that problem is, then they zoom in to look at how they can resolve it. And so the one problem that they were looking at is looking at the machine idle time. So what they realized after talking to people is that the machines were idling a significant amount of time. So you have an expensive piece of equipment over there. It costs in the millions of dollars. And this equipment is just idling there doing nothing. Okay, so they were asking why that is so. And so to understand that, that is where you want to come back to this simulation over here. So just imagine that this, let's say this yellow square over here is a workstation. So this workstation will be processing a job. You'll be manufacturing parts over there. And once it is done with a job, this workstation over here is going to call for the next job. And then this truck over here, this forklift, is then going to go and collect the next job and then bring it to this workstation over here. So I hope from here you can realize that if I wait until I complete my job before I call for the next job, then there's going to be a time where I will idle, right? The idle time is essentially the time where the forklift will have to go and fetch the next job over there. And so ideally what you want to do is you want to actually call for the next job while you're still working on your current job over there. Okay, and so that was what they have identified and how they plan to solve it. But of course, there is a problem. You cannot call it too early as well. If you call it too early, it arrives before your job, your current job is completed. It could potentially result in a mixing of the different job lots over there. And that in itself creates a lot of other complications toward this problem. So there's a balancing act that they need to do over here. I need to call it early, but I cannot call it too early over there. So what do I do? So what they did was basically they go about to gather the data, and then they build their simulation model. And once you have a simulation model, you can test different type of dispatch rules, right? I can say that I will call the job 5 minutes before I finish this job, 10 minutes before I finish this job, and so on. And when I say 5 minutes, you got to realize that in the real world, it's not going to be exactly 5 minutes. I estimate that it's going to be 5 minutes, but it could be 6 minutes, it could be 4 minutes as well. And so real world problems are complicated. And that's why you need the simulation model over here to test the different types of solutions. And so once you have this, then we are able to come up with a very concrete recommendation to Infineon over there. And so after this, then Infineon subsequently went on to implement the solution. So one thing I want to highlight over here, Henry, so one of the student over here, he was actually featured in Channel News Asia last year. So, and he was featured not because of this project, but he was featured because he actually went to join a tech startup over there. Okay, and so the idea over here is that if you are versatile, you can actually join any industry that you want over there. What you need to do is demonstrate the value that you can bring to the industry. So for someone like Henry, I believe his ability to do all this simulation is going to be very valuable to, let's say, a tech startup. And this very systematic mindset towards how to solve problems, those are going to be very useful as well. Okay, very quickly, I want to share another project that we have done. So this was with Ernst & Young. So Ernst & Young is actually an accounting firm. And so same thing, when they approached us, they were just asking us to look at their process. So this is their current business process. And they asked us, is there anything that we can do to help improve? So same approach, the students went down, talked to the people, they look at what are some of the problems. There was like human errors. So human errors is always a very big problem because once you have an error, you kind of need to go back again, right? So you reach a certain stage, you realize that there's an error, you got to go back again and then redo everything. So errors are something that we try to avoid as much as possible. And at the same time, a lot of work is being done manually over there. So in the interest of time, I'm not going to go into too much details, but essentially after they identified the problems, they came up with some ways to help automate some of these processes. But what I want to highlight over here is the results that they have obtained. So when they reported their results, this was how they reported it. So before their project, it took Ernst & Young about 3,000 minutes in order to process one job. After implementing their solution over there, the time it takes to process one job then drops to 1,500 minutes over there. Okay, so they reported it in terms of the percentage improvements, which is that you want to demonstrate the value to people and you can't just say it in a very vague way. You want to put it directly to them so that it's clear to them what type of value you can actually bring to the table. Okay, and so I probably talked enough about the system design project. Besides that, I think having do project work is also going to be important as well. As mentioned, a lot of real world problems are complicated. And so it's not like your textbook problems where it's well defined and you solve it. Okay, and so that's why project work is important. And at the same time, I always recommend for my students to go for internships because internships are where you demonstrate the ability to work with others in a professional settings. Just like in our system design project, you have to talk to different people to find out the problem. Nobody knows all the answers. And so you need to talk to the managers, you need to talk to the people on the ground, you need to talk to the IT people to get certain type of data and so on. So you need to know how to work with people and in a professional setting. And also in internships as well, I tell the students that you don't want to just put on your CV that I've done internship at company A, I've done internship at company B, and so on. Rather, you want to say that for my internship at company A, I have done this and achieved this amount of cost savings. For my internship at company B, I've done this and achieved this amount of cost savings over there. Okay, and so just quickly to summarize, I think in order for you to achieve all this, you have to start today. It's not one of those things that when you graduate, all these things miraculously fall into your CV. You got to start today to start building up your CV. So a few things you want to do is you want to build experience dealing with real world problems. Okay, so you're not constrained to just corporate type of problems, right? Look at your daily life. Look at how you do things. Look at how your family does things, and so on. Look at what are the things you can do to improve those, and those are also evidence of how you are able to deal with real world problems in order to achieve cost savings or to obtain maximize profits over them. The second thing that you want to learn is also how to work and interact with others. And once again, this is something that takes time. Okay, so this is where project work is very important because once you go out into the industry out there, you will have to work with people in order to get things done. The last one over here is to accumulate achievements that demonstrate your value, just like how our students have done in the system design project over there. On your CV, you don't want to say, I've done an internship at this company. You want to say, I've done, from my internship at this company, how much have I saved for this company over there? Okay, and just two last questions to leave with you. Why do mature hires command higher salary than fresh graduates? Why is it that companies will pay $10,000 for a mature hire, whereas a fresh graduate will only kind of get $4,000 over there? And the reason it's very simple is because the mature hire would actually demonstrate all these things above, right? They have a lot more experience in dealing with real world problems. They have a lot more achievements on their resume that the company can look at it and say, okay, this is somebody who can definitely bring value to my organization. And they have demonstrated that they are able to work and interact with others. If not, they wouldn't have been able to complete the projects that they have done. Another question that you want to think about, if you are a person, if you are the hiring manager, will you hire a top student who has no projects to speak forth? Or will you hire an average student who has done impressive projects, help companies solve problems, help companies achieve a lot of cost savings? Okay, so I leave this as an open question, but I hope that when you think about looking for a job, don't think about it from the perspective of a student. Don't think about it from the perspective of an interviewee. Think about it from the perspective of an interviewer. If you are the person who wants to hire, what are you looking out for? And once you go from that perspective, then I think you are able to better prepare yourself for that job search that's going to be upcoming. And so as promised, if you want to see, you want to find out more about the system design projects, we do have a few of those posters on our system design projects on our department website. So you can just check it out over here. The QR code is here, or if you want, you can just go ahead and use the link over here.